What is the benefits of going with inheritance? Any idea? Code reusability, and we have a maintainability is easy, right? Open for extension and closed for modification. Whenever you want to do proper inheritance, you always care about easier principle and LSP. So if you don't follow that, what will happen? We have discussed some of the problem issues with fragility as well as ripple effect. So even if you are not making any changes in the subclass, some new methods introduced in your parent will make a security hole. That's a ripple effect we discussed, right? And also how composition is comfortable compared to inheritance. But if you want to achieve a class hierarchy, polymorphism, easier relationship, then you can go for inheritance. Otherwise, the best thing is composition. That's what we discussed yesterday. Today, we are focusing on interaction diagram, which is a sequence diagram and object diagram. And today we are focusing on one template design pattern also we are discussing, and the polymorphism, more on polymorphism about static and dynamic binding we are discussing today. That's about our agenda. So here is the wholeness. We'll give you a summary of this chapter. So in an object-oriented program, objects collaborated with other objects to achieve the objectives of the program. Sequence diagram document, sequence diagrams document the sequence of calls among objects for a particular operations. Object diagram shows the relationship among the object and the association between them. They clarify the role of multiple instances of the same class. The principle of delegation clarifies the responsibilities of each class and its instances. Requests that arrive at a particular object but cannot properly be handled by the objects are delegated to other objects. Finally, polymorphism makes it possible to add new functionalities without modifying the existing code, which is open-close principle. The same way of SA knowledge, we use EML diagrams to capture the dynamic future of the system, representing dynamism in the form of static map, illustrate the principle that dynamism has its basis in and arises within the silence through regular TM practice. Okay, so first thing is, what are the interaction diagrams available? So there are several interaction diagram, for example, sequence diagram and collaboration diagram. We focus in this course only sequence diagram. So how different objects are interacted to achieve a particular purpose. So we are capturing the sequence diagram to identify the flow or interaction between the object for a one single scenario, which means of any use case. For example, deposit a money or withdraw a money. Take one use case and capture the flow between the objects by using the sequence diagram. So that's what we are going to discuss. It will tell you the communication between the running objects of that particular use case system. That's what we are discussing today. So our agenda, sequence diagram, object diagram, delegation and polymorphism, how the static and dynamic binding happen. We have to know the signature when we want to draw a sequence diagram. Some sequence of signature we need to follow. Who will start the action? So that will be shown as actor or an endpoint, depend on the UML software you use. Some software will show you actor icon, so we can show actor. Some software will not show actor, so we can use endpoint who start the action. And we can, on the top, we will represent object and its class. So if you're over here, we'll do like a reverse engineering. We have some code. From the code, we are going to capture the sequence diagram. So in that scenario, if the given code clearly says the object as well as the class name, I can specify on the top object name colon class name. But the code says you cannot identify what is the class name, then simply specify object name. You know the object name, but the code will not say who is the class name. So then in that scenario, you can say only class. So whatever the code gives, but the general syntax is object colon class name. This way, every object. Now, how can I send a message from one object to another object? So this is the line. You should have a line number and the message. The message is your method call. How you interact. So as we know, object-oriented programming, every object interact with other object by passing message. So that message with arguments, you can show it on this line. That's what this arrow lines. Then if the message is between one object to another object, your method call looks like this. But what happens if I call a method inside the same class, which is called as self call? Some method we are going to call it in the same account class. So that will be shown as a self call. If that object over here in this scenario, the customer object is interacting with account object. But this scenario is inside the account, it is going to call some behavior that is a self call. If that method returns some answers, so that will be show it as dotted arrow. That is a return message. So every object has some lifeline. So this dotted line is lifeline. How long this object are in the memory. Then we have several method calls, right? So this active bar is called as activation bar, which is the duration of a method. How long that method is in the call, which is in the stack. So if the method is over, then you can start another activation bar. Okay, so like that we have to do. So I'll show you with an example of everything. So here, whatever I explained is specified here. Please read out the theory. If you are not getting clear, I will draw the sequence diagram with the code. Then you will get a clear idea. Okay, right now read out the slide. Whatever I explained, it's here in the theoretical format. So this numbering, when you use star UML, the number comes from 1, 2, 3, 4. So when you use a rational row software, so that numbering is comes like 1, 1.1, 1.2, depends on that. Okay, so you can follow 1, 2, 3. That's absolutely fine. Okay, so that's what it's specified. Depends on the UML software you use.
Sequence diagram. We go from left to right or from top to
What do you mean by left to right?
so when we want to understand left right.
I will show you with the clear code and I'll draw the diagram. Then you will get clear, right? Okay.
What is it in real world?
What it is?
Diagram, yes.
Sequence diagram.
What is
This will capture the flow. If I want to perform a withdraw money, for example, in your ATM, what we need to do to withdraw your money, you need to insert a code, right? Then you have to verify the PIN number. Then you have to select an option. This flow until withdraw your money. I can show that flow in a sequence diagram. Okay, so let's capture this scenario. So I will use star UML to draw this diagram. So here is our code given to you. Create a sequence diagram. In your exam also the same scenario. Sequence diagram based on the flow that occurs when an actor invokes the check-in book method on a check-in form. So here our use case is check-in book. We are doing for a single use case scenario. Okay, you must use hierarchical numbering or what is that? That's you can ignore that. Okay, so for this scenario, we are going to start actor going to start from the check-in form. Okay, so they are going to do the use case as check-in book. So inside this check-in book, we have some code. It will going to contact the check-in controller. This is another object, right? So in that object, what message we are passing is, I want to pass checkbook. That is your message. The method calls are your message. So what is the argument for this message is book and member. So what happened when you call this method? Your control will automatically come to this method, right? So here inside this method, we are going to call another object, right? Did you notice? Get checkout record. This is a method call, right? Every method call is an object. So we have another object, which is a checkout record. Then from that checkout record, we are going to call a get due date. Then we are going to compute a fine. So this compute fine is a self call, right? Did you notice get due date? Where does this get due date comes from? Store record, which means another object. But when you call compute fine, which we are invoking inside the same check-in controller class. Then I'm going to remove the record. So here, which object you are interacting now? Member, which is another object, library member. Then I'm going to interact on another object, library DB system. My message is remove record. So now we are going to capture this code into a sequence diagram by applying the signature what we learned. Okay, so I will capture this scenario in a UML diagram. Okay, so I will use the sequence diagram syntax. Okay, go to your star UML. Okay, if you want to add a model, click on the model, add diagram, sequence diagram. So after selecting, you will get this. So when you see here, I don't find any actor, right? So there is no actor symbol. That depends on the software you use. Even I cannot see the endpoint. So what I can do in this scenario is you can open this text. Okay. Sometime we can show it as a stereotype, which is actor. Okay. So you can show by this when you use StarML. I don't know with the updated version, if you get that symbol endpoint. So endpoint means it looks like this. This dotted line is called endpoint. Okay. So here is our actor. Okay, so we need some line, then only I can interact it. Okay, let's see. Okay, let's see. Come to this coding part. Okay, so from the actor, where does this actor start from? Check-in form. They have that login form. Then they are going to do the messages, check-in book. So the check-in form, the actor is going to call a message, which is check-in book. Okay, so okay, that's check-in book. Where does this check-in book comes from? In the check-in form. So you need an object, right? So inside this one, I need an object. So what is your object here is check-in form. So now I don't know the object name, right? So I know only the class name here. So what I can do it is check-in form. So this is your first object, right? So this is your lifeline. So that will be state how long in the memory you can have. Maybe always the first one take the long memory. Okay. So from the actor, I think I can do it because it needs something object. Okay. Let me put a lifeline here because I don't have anything here. Okay. So I'll put as an actor here because if I want to interact, if it is an endpoint, it will come automatically. So for this scenario, I'm doing what you can do it is do everything from here, either a paint tool or some other tool, just draw actor to start this. Okay. So what is my first message here is, okay, I can move this here. Okay. So what is my first message? So when you do here, the line will come. So you have to interact from here to inside the check-in form. Okay, if you do it somewhere in the middle, it won't work. So what is the message here is your method call, right? So check-in book, your method name should be your message call. Okay, so you don't need to put a bracket. Okay, I think it won't accept when you put a bracket. Okay, it will be an error. Just the method of name of the method. Okay, so the number will come automatically. So this is how from the actor that maybe when you do the project, you have some UI, right? So the interact from the UI. So whatever name you want, you can provide it from here. So this is my first action. Okay. The next one is from this inside. So what will be our object here is check-in controller. I'm going to interact another object. So you need to introduce one more object into your code. Okay, what is the object? This is an object name, right? What is the class name here? So I know both names, right? So in that scenario, in the object, so what you can do, put both name. So it take a lot of space. I put a CC, okay, which is check-in controller. Then the name is check controller. Okay, I put short name. Okay, so CC is my object, but in your code it is check-in control. Okay, because I don't have space. That's what I do this one. Okay. Okay. The next one is, so this method is long method, right? So you can drag it because over here, this method end here, right? So inside that we do several tasks. So this is called method duration. So how long this method is in the memory? Okay. So this dotted line is how long the check-in form object in the memory. Make sense? Okay. So what will be my next task here is from the check-in form. So where I can initiate this action from check-in form to check-in controller. But what is the message here is checkbook. So the next is I'm going to do it will be from top to bottom. The first line is over, right? The next line, your message will interact from check-in form to the controller, but the message is called checkbook. And you have some arguments, right? So you can show the arguments inside the bracket. I hope it works. So you have to pass member book, comma, member, right? Okay. So let's see, does it accept? Yes. So you are going to pass member book and member. These are the two arguments you are passing. So this is your second message. Okay. So let me repeat the message. If you want to know, you can check from where we initiate this action. So that is your start arrow point. So where I'm going to call this one, the object name. So you have to draw the line from the source to the destination object. And the message line is method call with the arguments. Okay. So now what happened? Automatically your control will come to check-in controller. So this is another method, right? So what I need? Another activation bar. You can extend this bar, how long we use. Okay. Then you can reduce according to it. Okay. So from the check-in book controller. So what is my next line inside this code is from the library member, I am going to interact with the messages get checkout record. So inside check-in controller to member, right? That was the message call, right? From controller to the library member. So now I need to introduce an object, which is library member. So introduce another object. So do you have name and object here? Yes. So it will be member colon. I put library member. Okay. So if you know both, you can specify everything here. Okay. So now what is my third message here is from the controller to the library member, the message is get checkout record. So the third message is from here to here, the message name is get checkout record. Okay. So get checkout record. That is your message. We are going to pass book, right? So I can do here. So here you might wonder, do I need to return? Actually, it is a meaningful, right? When I call get record get method, definitely it will going to return. So right now we are not going to talk about return. So the return syntax we will be discussing later. Okay. So this is clear meaning. So I no need to do anything here. So directly I can do this checkout. Okay. So checkout of book. So what will be my next message? So it will return a store record. So if it is a different type, if you want to know how to store the return type, so the return type, you can store it after the method. Okay. Get checkout record. If something is returned, you can put colon and the value returned by this is store record. So even you can, if the method returns something, I think it doesn't show colon. It doesn't take. Okay. Maybe after the bracket. Okay. After the bracket, colon, store record. Okay, it doesn't accept. Okay. So different depends on the software. Okay. So you can. We have the return message link that we can use. I'll tell you about that later. Okay. So maybe I have some. Okay, so you can show it with here equal. Okay. So if you want to use star UML, so what I can do it is store record is equal to, okay, but not colon. If you use a rational root software, that will show like this. So now it's fine. In your star UML, if I want to see the store record, here is the idea, right? Store record is equal to member dot. Even you can so like this or with the return message. So this is returning an answer. So I can put store record is equal to this one. Okay. So any questions so far these 3 lines? Okay, let's go to the next line. What is my next line? From the controller class, what is your method called? Get due date, where we are interacting. Store record. So now we need to introduce an object which is a type of checkout record. So now we need to introduce one more object which is store record. I can extend this space. Okay, so then come over here. I don't know if I extend. Okay. Okay, let's introduce store record, another object. So store record, we know both names, right? Object name as well as class name. So your object name is, I use SR here, and the class name is checkout record. Okay. Checkout record. You can extend this line. Okay. Okay. So now you are going to initiate the message from controller class to checkout record. My message name is get due date. So here we are passing a message from checkout to checkout controller. Okay, I need this object. Okay, when I do this one. So you guys can reduce this one because the method is end, right? So you can reduce the duration. So next is from the message here to what happened? I have to drag this one. Yeah. Oh, the lifeline should be extended. Okay, so. Okay, if you use board, it is easy, right? Yes. Okay, so now from here, okay, so what happened? This line, okay, so message from check-in controller to the store record, sorry. Okay, from the whole record, what is the message here is? Get due date. So get due date, okay, which will return a date. So if you want to store this date, you can put date is equal to due date is equal. Okay, so this is my next message, right? So what will be your next line? You need to calculate compute fine. So where we initiate this call? Inside the check-in control. So which is a self call. So we are in the check-in controller. So extend this one. The next lesson is self message. So I am going to call within the class. So the message is compute fine. Okay. So do we pass some date? So we are passing the due date. Okay. So this is your self call. So what will be our next message? I'm going to call remove record. So the message is from controller to your library member. The message is called remove record. So from the controller, you are going to interact with the library member. What is the message here is remove record. Okay, so we are going to call remove of what we need to pass a book. Okay. Remove record of book. Okay, so this is our sixth message. So what will be our next message? We are going to interact with the library DB system dot remove record. So before that, first I need to get member ID. Did you notice? Inside this argument, we are calling member.getID. So first thing, I need to retrieve an ID. So how can I call this ID? From controller to your member, the message is getID. So from the controller to your library member, the message is getID. So getID. This is meaningful. It will return an ID. So if you want, you can retrieve in a variable and you can pass it. So get ID. Okay. Then what is your next method called? Library DB system. So which is not in the memory, right? Now we need to introduce library DB system. So I can extend this one. Okay, good. So now you have to introduce library DB system. We have only the object name. So I can put library DB system. Okay. Then you can extend this line. Okay. Then come over here. So how we are interacting from controller to your DB system. That is your message. So from the controller to your DB system. So from the okay, then I can reduce this size. Okay. Then I can extend this little more, this duration. Okay, the next is messages. So check-in controller to your library DB system. To your library DB system. So the messages remove record. So you need to pass ID and the store record, the variable name I use here is SR. Okay. Get checkout. Okay. Then now what will happen after this code? Your method is over. So now the lifeline should be done for this object. Then after that, what will be a call here is come to this one. We have method called display checkout info. So this is a self call. We are doing inside the check-in form. So come to your check-in form. Okay. So you have to put after this 8. Okay. So then it will look very good. So the self callers, the 9th messages. What is the message here is display checkout. Display info. Okay. Then what is your next message? Okay, let me extend the lifeline. Okay, then another self call, which is clear fields. Okay, clear fields. That's it. So this is the way you need to draw the sequence diagram. Let me repeat. You need some actor who start the action. So that may be an endpoint. Depends on the software, whatever tool you have, you can use it. So from here, we are going to initiate the action. Then this is user will interact into the check-in form by passing a message called check-in book. Then the next message is inside the check-in book, we are going to interact with the controller. The message is checkbook by passing an argument. So from check-in form to your controller, the message is checkbook by passing 2 arguments. So the next line is it will move the control to the checkbook. So inside this one, I'm going to call member.getCheckoutRecord. So the call is initiated from check-in controller to your member. The message is get checkout record. So the third message is get checkout record from the controller to your library member. The next call is I'm going to initiate call from check-in controller to your store record. This is another checkout record object. The message is get due date. So from the controller, we are going to interact with, sorry, this line I have to come. So, okay, get due date. We are going to call get checkout record. So after checkout record, we are doing compute find, which is a self call inside the check-in controller. So we do the self call. The next line is we are going to call library member from the check-in controller. The message is remove record by passing a book. So remove record from the controller to your library member. The next we are interacting with member.remove record. From the controller to your member object, the message is remove record. Then we are interacting with the library DB system. But before that, I need to get an ID from the controller to the member, get ID. Then remove record by passing this, interact with your library DB system. So now the method is over. The control will return to the next line of the method call. So here display checkout info. So this is a self call within the check-in form. So we do this one. Then clear checkout fields. Any questions here? So let me extend these lines. Give me a moment. Okay, go ahead. Yes, yes. So it has to increase this one activity. Yes. Okay, so that's it. Any other questions you have? Then we will extend the lifeline little bit. Yes. Okay, please take care when you draw it on our exam. Don't put the method duration long. So these are all short duration, right? When I get out checked record, the method is over, right? So depends on that, you can draw the activation bar. Look at here. These are all a method call. Once the call is done, it is over. It won't be in the memory. So the method calls, this should be when you draw, you have to be careful. Okay, yes. So the return we will talk about later. So that's it because I want to show you everything in this window. That's why I shortened, but you can go with the same name. Okay, if you want, you can short it. Okay, but put a note in the exam. Okay. Yeah, you can use the same name. Prefer the same name. That would be good. Yes, yes. In the reverse situation. So usually in your project, you are going to start from sequence diagram to design. So here we should know the scenario, right? How objects are interacting. For easy understanding, we are showing with the code. But when you start from design to code, you can capture the sequence diagram, then go for implementation. Okay. Any other questions? So this is for a single case scenario, right? So then you can easily draw. If you have multiple scenario, it's difficult. You are going to do the task for only check-in book or checkout. If you know the flow, that's fine. But this is what understanding, analysis, design, and coding. When you get good practice in your development, then you're not going to do this one, right?
What is the intention? I mean, in very complex systems, this one is going to be a lot.
So that time you can go for different diagrams. We have component diagram, some other interaction diagrams are available, right? So if you have some subsystems, right? How each system interacts in that. So here, how each object interact. So you can have different component diagram or something.
The code is already there. So what are we dealing with by just doing this one?
This is an understanding of the knowledge of sequence diagram. Okay, any other question? The simple scenario. For single use case, how can I know how many objects are involved in that? How can I show the flow? For better understanding, it's a diagrammatic representation. Yes.
There for each.
Yeah.
Each component, right? So we start from the diagram and the diagram will generate the code.
Yeah, auto-generated code. Yes, even the code to diagram also you can generate from diagram to code. You can generate. But as a programmer of beginner, if you want to learn something, you should know both. But you have all the software will give you auto-generated code or auto-generated diagrams. Even you can get it directly through code to diagram or diagram to code. Any other questions?
So this diagram is for one.
One use case. Yes. Yes. Yeah, that's what. For understanding someone coming into your team new, they could understand the flow.
In industry, this thing is very expensive and owner individually does not have wanted this kind of thing.
But you need to know the procedure, right? If something interview, they ask you question, why do we need, right? Then you should answer. All fundamental knowledge is very, very important for the interview purpose. When you go there, every day different softwares are coming. You have to learn. The developer cannot stop learning, right? Every day we need to learn. But the fundamentals are always same. The basics are always same, right? But there are different advanced technology will come. But this basic knowledge you need as a developer, you should know this. Any other questions?
Why do you consider it?
Because it's change, right? Keep the data will dynamically change, right? Depends on the scenario. The input may change or different objects may interact. Okay. It's not static, right? Maybe you can change some implementation. Then the flow will different change, right? You can change data type or something. Yes. Any other questions? Okay. In your homework, I capture for check-in book, you are going to do for checkout book. Okay, the code will be given to you. You have to draw the sequence diagram. Okay, so here is another scenario, one example of sequence diagram given here. The scenario is get hourly report. Okay, so the description has given to you the same like it is not a code. Okay, so just a scenario. Okay, we don't have any code. Okay, in a certain company. So this is from theory to sequence diagram. So what the scenario we look here is code to diagram. So here is the scenario. In a certain company, updates are provided every hour by each department that are placed on the department's queue to be read by the company administrator. So here is I have an actor. So the company administration can interact with the department to get their hourly report. Then that will be put it in a queue. So if you read the statement, to obtain a hourly report, the process is launched that invokes an admin module passing the reference to all the department. So admin can pass the reference to all the departments. So this is your first flow. Then after that, the process then asks the admin console to collect messages from each department queue. So then I have to call the company to collect the message. So now the department need to read the name and the I going to call a message. Then that information will be passed to the queue. Then after that, we have a self call to format the message. So this will be for several departments, right? So there are so many employees. So that will be a loop. So we need to do for each department. So the looping also will be discussed soon. So like that, we can capture with the theory statement also, we can have the scenario, then go with the scenario for implementation. We learn the both. Okay, so let me show you about the remaining things, the looping as well as the return statement. Okay, here we have another example. Just a theory knowledge. We don't have any code here. Okay, so we have an order and we are going to invoke a comment on it to calculate its price. So this is your task. To do that, the order needs to look at all the line items on the order. So which means one order can have multiple order lines. So we have to perform repeatedly for each order line, which are based on the pricing rules of the order line product. But we don't have clear idea about what is the pricing rule. Okay. Having done for all these line items, the order then needs to compute the overall discount, which is based on the rules tied to the customer. So here the UML diagram looks like this. So if you want to know more about this control system requirements, we uploaded a textbook here. You can go to the main textbooks, UML Digital 3rd edition of Java textbook. So this textbook will explain distributed and centralized control. We just capture the few part from this textbook to show you this one. Okay, so over here for this requirements, when you draw the sequence diagram for this requirements, you have an order line. Each order line has a product. So that belongs to the customer. So from this requirements, you can identify all the objects. So now as per this requirements, an actor need to calculate the price. So for calculating the price, they need to get a product quantity and the product name. So when you call this order line about the product, it is going to return the product. So now this is a return statement. So it will return a product. Then you are going to get the pricing details. So first get the product details from the order, then get the pricing details from the product. Then you are going to calculate the base price and the discount price. Then you are going to get the discount information from the customer. So this is the process. When you look at this one, most of the process we are using inside order class, right? So now this order class works like a major object, which is centralized control. The whole application depends on one object, which is order. So when we are in the analysis phase with the theory statement, our diagram will look like this. So everything is centralized control. When we go for implementation, we distribute this task to several other objects. Going for a designing part, your centralized control will came as distributed control. That's called as delegation. Delegate the job to other. So the diagram looks like centralized when we start in the analysis phase. But when we come for the designing space, see here, it becomes distributed control. Now the task is distributed to order line, and to the customer. So now look at the difference between the diagram. So what about this diagram? Right? Everything process done, order. So when we go for an implementation, that process time, your diagram will looks distribute. Okay, so this is an analysis space, centralized control, but the design space, we are not depending on single object. The task is distributed to several. So that's the idea captured from this textbook. If you want to know more about distributed control as well as centralized control, I recommend you to do the reading from this textbook. Okay, so here about this diagram. Okay, so please read out this. I explained those things. You can read out the theory. Let me know if you need more clarity on these points. Okay. So how do we show loops in a diagram? Okay, if you want to show the loops in a diagram, so over here in the previous system, we have several order line and several products. So how can I show this in a UML diagram? I need these things in a loop. Okay, to show the loop, there are different approaches. You can use it in star UML. The first one is nodes approach. The second one is iteration marker, which is asterisk. When I put asterisk on that line, which clearly indicates that it's a loop. And also you can use the interaction frame. When we use the interaction frame, you can show the coding part, how the loop execute. All those logic, you can show it on the interaction frame. But we use only iteration marker in this course. So this is the iteration marker. So when you see here, this get product, pricing details, and calculate price, which needs to do for loop. So these three messages, method calls are in a loop for each order line. So that's what you can combine all these three and put a note, which is for each order line. So this clear statement says that these are in the loop. So which one comes in the loop? You can put a note in this box like this. Otherwise, you can put an asterisk on these three. So which clearly says that it is a loop. So this is the approach we follow here. Any questions here? No. So there are two ways we shown. This is for asterisks and this is for notes. But in our course, we recommend to use iteration marker, which is stars. Okay. So this is I already explained you the syntax. On the top, you can represent the object by using object name : class name. So if you have the both, if you know, you can include both. From the requirements, you can able to know anyone, at least you must specify anyone. Okay. So here is an example of distributed control. So please read out this theory about distributed control. So you guys can do more reading about centralized and distributed control by referring the textbook. Okay, so you have one exercise to understand there's a distributed control. Okay, so here is the task. You have to create a class model diagram with your team with all association, multiplicity, role names, and a class diagram with attributes and operations. Have a discussion with your team. So we will get back again by after 15 minutes. Okay, you can take break as well as work on this exercise. 11:05, I'll get back to you. Okay, so please don't look at the next slide. Stay on this slide and do the diagram for this. Okay.